So I'm starting with the last example, minus 44. So I just switch to a negative value of 44. And of course, so we're being asked to convert the following decimal numbers to hexadecimal representations. You can see that minus 44, in my case, is represented by hexadecimal by all of these formats, right? So in a byte size quantity, this should be read as hexadecimal D4. Again, the following examples just use a specific bitwise pattern using 16-bit binary numbers. So I'll let you do the computation, practice it in your calculator, and try to figure it out what this is. But just remember that in 2's complement notation, it's always true that if the leftmost bit is set to 1, it means that the number is negative. So whether you're using the calculator or whether you're using just a pen and pencil approach to compute the results, just keep this in mind. Let's just try one of these examples for practice. So here I need to be able to compute these two numbers. I just reduce them to hexadecimal notation in this form, and I'll try using my calculator for this. So let me clear the result, and I am observing that it's the size of my inputs is 16-bit because each hexadecimal digit is a 4-bit pattern. So I should be using a word format. Right, so this is word format. Now let's enter the first number, 7D96. Plus F0A0, and add them together. So this gives us the answer 6E36. This is the correct answer, and you can see that this is actually a positive number. It's decimal 28,214. Right? But the most important thing to recognize in this exercise is that the size of the input data, because we're dealing with 2's complement notation, and so the calculator will do it for you correctly if you keep the size of the data correct. So in my case, I'm observing that I have 1, 2, 3, 4 hexadecimal digits. Each single one of them corresponds to 4 bits. And therefore, my input size is something that is called word in Intel world, and this is 16 bits. So word is 16 bits data type. And you can see that all I had to do is just go ahead and punch in the numbers, and I got the right result. This is the right answer for this exercise. Perform logical operations and express your answers in hexadecimal notation. So we discussed all of this already, and I guess what we need to do is just, again, that would be a nice idea to continue using the calculator to make sure that the calculator gives us the correct answer. Let's just try the first example right here. I'll clear this and carefully input 5478, and then choose a bitwise operator AND. You see that now the calculator remembers this value, and then enter the second number, FDEA, and equals. So this is the answer, 5468. This is the correct answer. So once again, the most important part of this exercise is to make sure that we choose the correct data type for our inputs. You can observe that we're trying to use bit patterns which are 16-bit size, expressed as hexadecimal digits right here. So I am using, as you can see, the word format is 16-bit size values. Fill in the truth table based on these outcomes. Again, I would just let you try using these bitwise operators and make sure that you provide the answers. Just simply copy this truth table over to your answer and compute these expressions, which are using bitwise not and following the right parentheses rules, all the grouping, and replace the question marks with the right answers. This is quite similar exercise. So once again, you just like copy this portion, paste this in, and provide your answers. So you should be able to apply this quite successfully to just individual digits. And this is it for this presentation of laboratory exercises. Make sure that you save your changes often, and when you're done, you can submit for grading. When you click submit for grading, it will ask you for the confirmation. I'm not going to submit this form because it's not finished, so I'm just going to return to the main menu. So let's check our weekly assignments one more time. And remember, there is another assignment for you to do, which is very similar to Lab 1. We keep practicing with binary arithmetics and binary encodings. And this time it's called assignment A1. So you need to fill out this form as well. And you can see the due date is a couple of weeks from the beginning of the semester.